Hello chemists, in this video we're going to be covering a little bit more kinetics, and we're going to specifically be looking at initial rate of reaction.
Greetings chemists, some more kinetics questions for you. Here we've got a reaction between A and B, classic labels for reactants, and in an experiment the concentration of A was measured at regular intervals as the reaction proceeded. Great. So we've got a concentration time graph, concentration of A with respect to time, and I've got to draw a tangent to the curve at t equals 0, and from there determine the gradient of the tangent to get the initial rate. Okay, well, to save time, the tangent is already drawn. Let's figure out what values this is going to give us. Okay, so we can draw a little triangle. So let's just pick these 2 points. We're going to pick that point on the tangent, and we're going to pick that point on the tangent. So then the rate, which is equal to the gradient of the tangent, is equal to the change in y over the change in x. So y2 take away y1 all over x2 take away x1. Okay, so y2 is 0.5, and then y1 is 0. Great. Now x2 is 11.5 and x1 is 0, so this becomes 0.5 over 11.5. so let's get the trusty calculator out. Right, clear it from the previous calculation. What are we gonna get? 1 over 23. Don't write it as a fraction. So this is 0.043. And what are the units? Okay, so what I really should do, and let's do it proper. Let's do it properly. Okay, my y has units of multiple decimeter cubed. My x has units of seconds, so this is going to be 0.043 moles per decimeter cubed per second, which are the units of rate. Lovely jubbly. Cool. Fantastic. Right, next question. The reaction is carried out again under identical conditions of temperature, hurrah, with the same starting concentration of B, but using a different initial concentration of A. Now, this is only a cheeky 2-marker, but I think reading the examiner's reports, they said that their language, not mine, that this question discriminated for whatever reason. But let's have a look at some easy ways of tackling this, okay? So first things first, do we know what the rate equation is? Yes, we do. Let's write it down. That the rate equals K A squared multiplied by the concentration of B. So we can actually use this rate equation to help us, okay? Now, same temperature and same starting concentration of B. So what we can do is ignore the K for a second. Just ignore the K. So there is my concentration of A, and the change that I'm making to that concentration of A, what factor I'm changing that concentration by, okay? So over here, what we're going to do, this is the factor by which the concentration of A changes or is increased or decreased, whatever. Okay, and we're going to do the same thing here with B, and we are going to say that this is the factor by which the conc of B is increased or decreased, or whether it stays the same, okay? So in the second experiment, the initial rate, so I've got to go back in just a second and figure out what the rate was. In fact, I don't even need to do that, do I? I don't even need to do that because it tells me that the initial rate was changed or was a factor of 1.7 times greater than in the first experiment. Okay, lovely. Where do we go next? So let's put that information down as well. So the rate was times 1.7 times greater, increased. Okay, so let's write that down as well as part of our working out, as part of the explanation. Let's do that in blue. Okay. So what we're saying here is the factor by which the rate increased. Okay, so now we can start looking at the changes we've made to the concentration of A and the changes we've made to the concentration of B. What factors have we increased those by? So we haven't changed the concentration of B. We've got the same starting concentration of B. So we've kept that constant. So let's just say we've times it by 1. Okay, raised to the power of 1. So that is 1. Okay, what factor has A increased by? What factor is A increased by? Now we don't know. We don't know, but that is squared. Okay, so let's just put times, I don't know. Let's think of a symbol that we can use here. Let's go with times A, because why not? Now we can just get rid of, or we can reduce this to times 1.7 is equal to times A squared. Okay, so then to figure out the factor by which A has increased by, what do we need to do? We need to take square roots of both sides, right? So the square root of 1.7 is equal to the change or the factor by which A has increased. So what is root 1.7? Let's get our calculator out. So square root of 1.7 equals 1.30384. 1.30384. That's how much the A has increased by in experiment 2. Well, to do this, I actually need to know what the initial concentration was in the first experiment. So the initial concentration of A in the first experiment was 0.5. So I'm just going to say exp1, concentration of A is equal to 0.5. And then in experiment 2, I know that the concentration increased by 1.30384, whatever. So that means, let's say it out a better way actually. To get the new concentration in experiment 2, what do I have to do? I have to multiply 0.5 by that factor. So what do we get? Times that by 0.5. And hey presto, we get the answer, which is 0.65 is the new initial concentration of A. Lovely, really good question. Really good question. I can see why it discriminated. But we should be able to pick up some marks on that, I think. All right, thank you very much for watching. Catch you next time, maybe for some more kinetics.
If you found this video useful, make sure to hit that subscribe button. If you want extra help, sign up to our courses, where you'll find the link in the description. And you will get weekly live lessons with us, targeted homework, video solutions for the homework, and even workbooks. Just what you need to give you the extra boost for your exams. Thank you for watching. See you guys in the next one.